Hello, how we doing? Alright, let's do this. Alright, hello, Sneaky Weasel, how we doing today? I hope we're doing good today. How is everybody today? How is everyone today? I'm doing absolutely fantastic. It's a good day today already. Good day already. We get to do a little bit more. Of a good day. Now we get to teach some math. Not a bad thing. How's your, How was, hopefully you're rest and relaxed this morning, Sneaky. I don't know what it is about you. I was like getting up a little bit though. I got up in the middle of the night, then I went back to sleep, and then I got back in the middle of the night, and then I got back to sleep. My body's like, I want you to wake up. I want you to go back to sleep. Alright. Really weird how it works some nights. You ready for... You're really productive this morning? Heck yeah. We're working on some math homework right now. Oh, I see. Oh. I understand. Wouldn't be because, you know, things are due next week, maybe? Hopefully we finish up that homework and tests and stuff, so... Excellent! Excellent! I'm glad you're understanding probability this time. Very good. Means this go-around is much better than the first go-around. In high school, I was so confused because we only spent 2 weeks on probability. Oh, man. That sucks, yo. 2 weeks? That's it? Like, probability is a pretty big deal. And I'll be honest with you. The amount of stuff that you do in statistics and probability, and the amount of things that it actually affects in the real world are quite staggering, to be perfectly honest. Like, entire business decisions, you know? I know way too much about quadratics now. I mean, that's nice. But I was just like, I want to look at something realistic. I just like how statistics works out. Be like, hey, if I'm in a business, I need to talk about business decisions. I'm going to use statistics to do it. Because that's how it really works. Got the team of people. Yes, Yusuf! How we doing, my dude? How you doing, my friend? There we go. We're gonna get started here, ladies and gentlemen, in a few minutes, by the way. So, Algebra 2 is way focused? Yeah, that's true. I'm going for psychology and you know how to read stats and do experiments and what I'm doing. Yeah, that's true. If you're doing psychology, absolutely 100%. Stats is incredibly important for previous past precedents. The human condition is very important to understand, at least from a ballpark assessment. A lot of people gave me weird looks when I'm taking stats this semester. Why? Why would they give you weird looks? What's wrong with them? Clearly they don't understand. Good. I can't wait to see a person tested too much. Yeah, man. Me too, Yusuf. 100%. I look very forward to seeing you in less than 2 months from now, my man. 100%. I'm really excited, to be honest, Yusuf. You're taking a super hard class as a senior in high school? Okay. Well, look. I don't know about... Yes, I don't know. I don't find this stuff to be, like, super duper hard. Maybe thinking is a little bit too difficult for them, Sneaky Weasel. I don't know what to tell you there, alright? Like, I don't want to think about numbers, it's so hard. Have I sorted out where I'm staying? Yes, yes, Yusuf. I'm going to be in the Whitechapel area. By, Aldgate East. So that's where I'm staying right now. Now, where I go after that, besides going to games, of course, yeah, I have no idea what's gonna happen. I'll be going around some places. Apparently, I have relatives in different places, so I have relatives in Birmingham and Gillingham, according to my father. So I'm like, alright, I guess I can visit relatives. I have relatives I don't even know exist, to be honest. It's kind of crazy, to be honest. You have to pay attention, that's pretty much... Yeah, that's all you gotta do. But really, you know the most important part, Sneaky, in this class, is really just understanding the logic. Once you understand the logic, this class becomes significantly easier. I always point out the one most important thing in a lot of the problems that we do together, right? One of the most important things that I always point out in this class, and if you haven't picked it, you pick up on it really quick, is that the wording in the problem here is going to dictate exactly what you're going to do. Some people want to put a blanket statement on everything, like it's always going to go one direction. But then you just read the problem, or you think about it for just, like, thinking about it for 5-10 seconds, just think about it a little bit longer. Then you're like, okay, I gotta go in this certain direction. This is where the logic is going to take me, and this is the process I gotta do in order to do it. And I feel that people kind of miss on that. I struggle with logic, to be honest. I used to just let it... Yeah, yeah. You know what? That's fine. You know what? I struggle with logic, too, to be honest. I wasn't very good at math for a while. Alright, what? The only thing I understood about logic is that there's a set of rules, and you go one step at a time. Because if you're like, a computer's gonna do that for you, it's gonna do one step at a time to do, its calculations. Why don't I do the same thing as a computer does? Well, okay. And that to me is like logic, just taking one step at a time, following the rules, and then getting to your destination. And as soon I'm like dead serious here, Sneaky. Once I started going one step at a time, and not trying to go like doing the old skip a step process, like when you're climbing up steps, it becomes significantly easier. In all honesty, it becomes significantly easier. I just found that to be significantly easier for me. Now, if you follow that same process, trust me, I don't know. Going slow just made it easier for me to understand something that I didn't. Hopefully I don't get lost. Yusuf, I can't get lost on my first day. Yusuf, that's like not... Yusuf, I can't do it. If I get lost on my first day, I'm gonna be screwed. Alright? Because I have to get... Yusuf. I have to get off the plane. I gotta find my way over to my lodging. I gotta drop off my stuff. Wait. Come back. Get checked in. Shower change. Hop on that train. Get straight to Pitsea. And then I gotta make sure I find my way to the Len Salmon. And I gotta do that all on the first day. That's what I gotta do, Yusuf, my dude. Like, it's gonna have to be successful. Alright? I don't have a choice in the matter. Because if I'm gonna come see you, I'm gonna come see everybody else at the Len Salmon. I gotta make sure that everything is on point, 100%. Alright, ladies and gentlemen, we are going to go ahead and get started here with some new material. Let's do it. Alright, let's get going. Let's do some intros. Alright, let's go. Okay, let's get started today. Welcome back to Thursday. End of the week time today, everybody. Alright, so for today, ladies and gentlemen, today we are going into a brand new chapter here, Chapter 10. Alright, Chapter 10 is going to be talking about a brand new chapter with a brand new material. We're going to be talking about, specifically, we're going to be talking about hypothesis testing. Hey, howdy, how you doing, my friend? Take care, howdy. Today we're talking about hypothesis testing. Now, I do want to preface it by saying this. Chapters 10, 11, and 12 will all encompass pretty much hypothesis testing in different forms, okay? So a lot of what we're going to be talking about here today is going to talk about kind of those fundamentals when it comes to hypothesis testing. And then we'll also look at section 10.2 here today, which is a application of one type of hypothesis testing here. So we're going to go through things very carefully here today. I'm going to be perfectly honest with you here today, with at least the beginning part of chapter 10. There's going to be a lot of information here. I'll point out what the important bits are, so that way we can go ahead and see exactly how we can handle some of these hypothesis testing problems, as they kind of follow a similar pattern. Most of these problems follow a very similar pattern, and so we're going to talk about what that similar pattern is, or at least what to do in certain situations. In any case, I'm blathering on, whatever. Alright, blah 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 is what I'm doing. We need to change the big board here. We need to see what we're doing. Alright, let's do it. Alrighty. Okay, so now we'll come back to the textbook here in a moment, but we need to take a look specifically here at the handout for today. So let's look at the handout here for sections 10.1 and 10.2, and we are going to be talking about, like I said, hypothesis testing. Alright, now we need to establish some very important definitions, okay? So let's establish these important definitions, and then we're going to go ahead and move forward. This music's pretty loud. Let's turn that down. Alright. Here we go. Okay, so let's take a look at question 1 here. Now, we're going to have two types of hypotheses here, okay? We're going to have two types of hypotheses here. Now, I would highly suggest, 100%, that definitely write these down, take a screenshot, whatever you want. Okay, like I said, we're going to talk about these here in great detail. You're going to see me in a lot of examples that we're going to be doing here. You'll see me with the same notation here over and over again. All right, so we're going to have two types of hypotheses here. First of all, we're going to talk about the null hypothesis. So what is the null hypothesis here? Well, the notation here is going to be H0. Okay, so H0 here is going to be referenced as the null hypothesis. Now, the null hypothesis is the base case or baseline you are testing against. So if we need to do a hypothesis testing, we need to compare two things from each other here. We first have a baseline that we're going to be working with. So that's going to be the null hypothesis. Now, the comparison is going to come down to the alternate hypothesis. And that is question number 2 here on the handout. What is the alternate hypothesis? Now, the alternate hypothesis here, the notation is given to us as H1. The alternate hypothesis is the claim made by the researcher in the question given in comparison to the null hypothesis. All right, so the researcher is going to do a little bit of a study, and then they're going to make a claim based on their results, in comparison to the base case that they were given here. Okay. Now, as it says here, and as I say all the time here, wording is extremely important, very important here. You need to read the problem carefully. Very, very important. You need to read the problem carefully. Because, why do we need to read the problem very carefully? Well, simply because of the very next question on the handout. Let's talk about that. Now, if there's anything else you need to write down here, it will be question number 3. Question 3 here asks, what are left-tailed, right-tailed, and two-tailed alternate hypotheses? So if we go back to our base definition here of an alternate hypothesis, it's the claim in comparison to the null hypothesis. So in this case, we're going to have 3 cases that we can fall underneath: the left tail, right tail, and two tail hypothesis. Now, the first thing that we do here is we first establish our base case, our null hypothesis. So we take some parameter, set that equal to some value. Like I said, I know this is information for right now, but we're going to look at a practical example here in the next section, so which we will also be doing here today. So we'll see exactly how this works out. It's not as hard as it looks, though. Or maybe even this section. Anyway, I digress. So we have a null hypothesis here. We set some parameter equal to some value. A left tail hypothesis, a left tail alternate hypothesis is if we take that sum parameter and it's less than that sum value. That's the same sum value here that we have in our null hypothesis. So less than. Right tail means it's bigger than. Okay, that alternate hypothesis will be bigger than. And two tail will be it's not equal to. Okay, so again, less than, left tail, right, bigger than, right tail, not equal to, two tail. All right? All right, so I'm just making sure you guys understand, again, left and right and two tail here. Very important. All right. So we have our null and alternate hypothesis and the 3 cases that are involved. All right, that's fine. Now, before I move forward here, are there any questions so far? We're going to be looking at some examples here, so I know this doesn't make much sense. But any questions so far? Okay. Okay. So I just want to apologize ahead in advance, you guys. I know a lot of this is information here, so apologies for the information dump. If you need me to go back and scroll back because you didn't get a chance to look at the info, please just let me know, okay? All right. Now, let's take a look here at question number 4. All right. Now, we're going to be doing these hypothesis testing problems. And we do, like, all these steps. We're going to do a whole bunch of steps here and all this other jazz. But I want to tell you something here that is very important. And that is, the nicest part about these questions is going to come down to the fact that we only have 2 possible answers in our hypothesis testing problems. That's it. We have 2 possible answers. All right? So that you get down to the final answer, there's only 2 possible conclusions or 2 possible answers that you can get with a hypothesis testing problem. All right? And so, what are those 2 conclusions or 2 final answers that we can get? One of these 2 is going to happen. So the first final answer you're going to get is you're going to accept the null hypothesis and reject the alternate hypothesis. AKA, this is also called do not reject the null hypothesis. So you'll also see that on the homework there. Do not reject the null hypothesis. So, but accept the null hypothesis and reject the alternate. Now, the second one here is to reject the null hypothesis and accept the alternate hypothesis. So either you accept the null and reject the alternate, or reject the null and accept the alternate. Okay. These are the only two possible answers that you are going to get for all of these problems that we're going to see with hypothesis testing in some form or fashion. That's pretty much how we're going to approach this. So I want to streamline this as much as possible, and this is how we're going to start streamlining it, excuse me, in some capacity. Will be here in question number 4. And you'll see this come up time and time and time again. Okay. Okay. Let's look at some other questions here. We'll need to bang out some other questions here. All right, question number 5. What are type 1 and type 2 errors? Now, this is the first section here, at least section 10.1, talk about type 1 and type 2 errors. And we will be using it in a slightly different capacity, but at least let's talk about the definitions here. The type 1 error is if the alternate, if the null hypothesis is true in reality, but you rejected it in your hypothesis testing. So let's say you did all the testing, and it happened to be that the original baseline is true, but your results show that you rejected it. That can happen here. That's type 1 error. Again, a type 2 error is if the alternate hypothesis actually was true in reality, but you rejected it in your hypothesis testing. Okay. So, so in fact, the alternate was true, your research was correct, but for some reason, you found that the baseline was true. You found that, so you rejected it actually outright. And that can happen. And again, that just happens in certain tests, certain surveys. That's just how results can pan out. There could be a percentage, like we talked about here last time in chapter 9, there was a margin of error that we can deal with. And that's essentially what these type 1 and type 2 errors refer to here, is that kind of margin of error, okay? Used in the context of a null and alternate hypothesis. All right, fine. That's all well and good. Great. All right. Let's take a good look here at number 6. Okay, number 6. Number 6 is, what is a critical value? Now, we did talk about critical values here previously. In confidence levels. We briefly mentioned it when we talked about finding, say, a necessary sample size or something akin to that. Now, in this particular case, I'm just going to make a note. I made a note here. It says critical values will be used in comparison in determining a conclusion in some hypothesis testing. So certain types of hypothesis testing will be using critical values, and we will go over this where it's necessary depending on the section. So certain sections will use critical values, and we'll talk about it. If I feel that there's a need to talk about it, then we'll talk about the critical values associated with that process. If I don't feel that it's necessary, then I'm not going to really talk about it. I'll basically kind of ignore the process involving critical values. For the most part, we're going to be doing stuff here, just to give you a heads up. For the most part, we're going to be doing stuff here with the calculator and figuring out how to get our certain conclusions here using the calculator. But there are a couple of sections where we have to use critical values. But when we get to that, we'll get to that when we cross that bridge. I'll discuss about that. All right. Okay. Let's take a good look here at number 7, and then we'll take a look at some things here before we move on. Number 7. What is a significance level? Now, part of this process here is going to discuss regarding this significance level. And the notation here is given to us as alpha. What's the definition of significance level? Well, the level of significance or significance level, whichever you want to call it, is the probability of making a type 1 error. Okay? You will be given this value here in question. So you don't have to go ahead and find this. You'll be given this value here in question here. So the level of significance, the probability of making a type 1 error. So if we go back to type 1 error, again, the probability of saying, oh, if the null was true, but you rejected hypothesis testing. So we actually use this as a way of our margin of error here, is this level of significance. Now, all right, that's a lot of speaking, all right? A lot of speaking. In 15 minutes, I've laid down 7 questions of information. So I totally understand that this feels very overwhelming at this point in time. But now, now that I have that, out of the way, all right, now let's slow it down for just a second, because what I want to do is take all of this stuff that we've just talked about here in these first 7 questions. I want to coalesce it together into a process in where we're doing this type of hypothesis testing and see where it fits in. Now, to get you prepared for that, though, let's do some examples here, first and foremost. Probably saying, what are you talking about? Well, alright. Okay. I'll show you what I'm talking about here. And actually, let me put this on the... Okay. Alright, so a lot of questions here are going to revolve around certain important aspects. Let me show you what I'm talking about here. So if I look at number 36 here, for example, okay, so let's look at 36 here, and let's do this together, okay? I'm going to go slow over this particular example just to showcase, hey, how do we set up part of this problem? So according to popcorn.org, the mean consumption of popcorn annually by Americans is 54 quarts. The marketing division of popcorn.org unleashes an aggressive campaign designed to get Americans to consume even more popcorn. All right. Determine the null and alternative hypothesis that would be used to test the effectiveness of the marketing campaign. Okay, so this is the part I wanted to discuss here. All right. So let's just do part A. Now, first and foremost here, we talk about the null hypothesis. We talk about the null hypothesis here. So the question is, how do we look at the null hypothesis? Remember, if we talk about the null hypothesis, that's going to be our base case, our baseline here. So if we look at the problem here carefully, all right, just reading this off here very carefully, notice it says this. It says that the mean consumption of popcorn annually by Americans is 54 quarts. So then, right now, as they're doing the testing before they start this marketing campaign, I said, all right, the mean is 54. So we're going to start with that baseline and work and see what we're going to get. So we're going to have here the mean. Actually, that's not the sample mean. The other mean there. Let me put the right mean down. All right, so the mean here is going to be 54. Okay. All right. Now, before I move forward here, I want to go one at a time here with you guys. Are there any questions about how I defined here the null hypothesis? Does everybody understand what I'm going to be doing here in that very first part? I want to be sure everybody's on the same page here, okay? No questions? Okay. How I got 54? Or how I... Well, 54 is given to us here in the problem here, Victoria. But again, the important part here is they're going to give you some random number here, Victoria. So, now, okay, the null hypothesis here is again going to be our base case, right? This is going to be the starting point about where we're going to make our comparison, okay? So in this question, they say, okay, the mean consumption of popcorn right now, annually, by all Americans is 54 quarts, okay? So if I'm going to say, hey, I want to make that more, or I'm trying to, I have things I want to do, it says, all right, well, the mean here is going to be equal to 54. This is my starting baseline that I want to make a comparison with. That's what I want to do. Okay? That's essentially going to be your null hypothesis here. All right? Does that does that make sense? Are there any questions about that? You're gonna start off with something equal to some number. It'll be like it says here. Let me go back here for just a second. Let me go back here for just a second, guys. Just to hopefully make it. You're gonna have some parameter. In this case, the mean is equal to some value. In this case, 54. Okay. That's how we're gonna set up every time we do this. It's gonna be looking like this every single time. It'll look exactly like what you see here on the screen for the null hypothesis. Every time. Now, as for the alternative hypothesis here, I can't speak, but we'll go with it. All right. So we have to make an alternate hypothesis. Now, this alternate hypothesis has to be less than, bigger than, or not equal to that some value. All right. Now, here's a hint for you guys for the alternate hypothesis. All you need to do is you're going to use the same sum parameter, and you're going to use the same number. This number here does not change, okay? I want to put a note in regards to that, actually. Let's put that here. Okay. This number does not change, all right? At no time between null and alternate hypothesis will this number change at any moment in time, okay, guys? If you change this number, you'll automatically get it wrong. That's just how it is. Okay? Now, the thing that we have to do, though, is if we know that the value is not going to change, and of course the parameter isn't going to change either. The one thing that does change, of course, is what we're going to put in the middle. Either less than, bigger than, or not equal to. And in this case, we have to read the problem carefully in order to actually determine which one of the three that we're going to put down. So, looking at this, let's see what we have here. All right, looking at 36. What do you guys think? Do you guys think it's going to be less than 54, more than 54, bigger than 54, or not equal to 54? Alex thinks it's bigger than. All right, more than. Very good. That is correct. The answer indeed is going to be more than. Let's take a look about why. Okay. Now again, everything comes down to wording here. Let's read the last sentence of this question. The marketing division of this organization unleashes a campaign designed to get Americans to consume even more popcorn. So they want to make this campaign so you have more than the 54 than they currently consume. So that's the key word there in order to determine you have more than. Right? Absolutely true. Okay. So, what type of test do we have here? Do we have a left tail test, a right tail test, or a two tail test? What type of test do we have here? Left tail, right tail, or two tail? Back to our guy. And that is correct. Good. The answer is, that's absolutely correct. It is a right tail test. Nice. Good. Excellent. All right, so this is a right tail test here. So we've now established a null hypothesis, an alternate hypothesis, and we also found out what type of test we would have to run in our particular hypothesis testing for whatever we're going to be doing. Excellent. Perfect. All right. Good stuff. Rabia, 36 is the number for the problem in the book. I'm just doing problem 36 there, Rabia. I promise. Just doing problem 36. This is on page, what page is this on? 479? Alright. That's okay. Alright. Okay. Any questions? Any questions about that? Any questions? Okay, let's try another one. Alright, I want you guys kind of get prepped for these. Let's try another one, okay? Sure. Yeah, that's a good one, actually. I'm gonna do number 20. Yeah, it's the logic. That's right, Sneaky. You have to set yourself up with the logic first, and then you can proceed to do what you want to do after that. Just like anything in critical situations, you gotta actively think through the situation in order to make a proper determination. I once saved myself like that. That was actually pretty interesting. Almost got into a car accident. I'm like, oh, let me logically think through the situation before I hurt myself. Okay, let's look at the 20 here. How'd that happen? So I was driving. So there's like a 2-lane road, right? So there was a 2-lane road, and it was winter time, and so I'm how would I put this? All right, so the way I could put this is, all right, I'm driving behind this car, right? And you know, things are pretty slick on the road because it was snowed the day before, and you know, temperature's pretty cold. So this is like the car right here in front of me, and I'm like about, you know, maybe a car length and a half back. I don't tailgate at all, but I'm a car length and a half back. And then there's a set of railroad tracks like right here. So of course this and then there's like a little entranceway over here. Now I know this seems kind of weird, but okay, suddenly this car basically stops all of a sudden and wants to turn left over here, right? So of course, what do? I'm going a little fast, but not too fast. But of course, I start to I want to slow down. Unfortunately, my tires start slipping, and I got like a car length. I got a car length and a half before I rear end his car. So and I of course have to. I'm thinking, okay, there's two ways you can handle that situation. All right. Number one, I had to think through it logically. So number one, I can't go off to the left here because I'm coming into oncoming traffic, and I'm going to absolutely obliterate myself. All right. Number two, I could rear end him. All right. I could rear end him. You know, if I were to go into a panic. All right. That would be another situation. The third situation that I thought of in that fraction of a second. Yeah, I know. You have to stay calm in that situation. If you stay calm in that situation, you can think things through really quickly. So I thought about the third situation is that there was a small little area right here. I'm like, I'm going to turn into this area. I'm going to get into the ditch with all this snow over here. All right. And then my car is going to end up in a ditch in the snow that I hopefully can get out of. And then there you go. You know, but I had to do that I had to make that determination about, you know, while my car is skidding at the same time before I rear end it. So what happens is let me show you what happened here. What happens is that I'm about a half a car length away. So now I'm about this distance here. If I were to redraw my car at the time. It's not the only incident that I've actually saved my ass with logic. So, but Yeah, so now I'm a half a car length away, and then at that moment in time, because, you know, at that point, I didn't take a sharp right. I just kind of take a sharp right, I go into the ditch, and I avoid an accident. The car ends up in the ditch. I was able to get myself out after breathing for about, I don't know, a minute. And then there you go. Accident avoided. And everybody wins! So yeah, remaining calm in a situation and then logically thinking through your choices can be really helpful in certain situations. Especially for driving, I use a lot of logic when I drive. I use a lot of logic when I drive. I could tell you the other incident that happened to me. This is actually using logic in this way. This actually happened on 90 heading toward the airport, right? Now, if there's anything that you have to do, there's one piece of logical advice that I suggest everyone follows, okay, regardless of what you do when you're driving, okay? And this logic may seem silly, but it works, okay? The logic for driving is simple. Yeah. Is that everyone this logic for driving. Everyone on the road is an idiot, including yourself. This is true. Okay? You all suck at driving. Everyone here sucks at driving. Y'all can't drive worth crap, and neither can I. Alright? So, I always say the same thing. Everyone is terrible at driving. They have no idea what they're doing. You know, you have a 2,000-pound machine, and you're driving it on the road, and if you're gonna go swerve around and be like a dum-dums, alright, then I have to factor in that you're going to be a dum-dum. Alright, it's the same thing as like, you guys have been in this situation, you're on a highway, you know, you have some guy on the left-hand lane who's gonna swerve through traffic like crazy. What do? Do you race them or do you do stupid stuff? I said, no, you let them do whatever they want to do. Because at the end of the day, they're gonna end up doing something stupid. That's what it is. You leave it alone. That's the logical thing to do. Some situations, sometimes you're not given the choice, though, which I totally understand. Alright? In this situation, I wasn't given the choice. But, by being logical and by being aware, it really helped out a lot. So, I got into a very classic situation here. Classic situation is, I'm on the road, I'm over by the exit toward the airport, on 90, heading down toward the city. And so, I was going to get off at the next exit anyway. So, here's the situation. This car had come in and merged in from the... This is the lanes. Let's go with the lanes here. And you guys have probably been in this... Honestly, you guys have been in this situation before. So, probably at least more than once. Car comes... Alright, car is over here. It wants to go over here. Somewhere over here. Alright? Now, of course, this car had just gotten in. This car's not smart. I'm right here. I'm right here. This car, now, I have a big phobia about one thing, and that is when people are on this side of the lane. Now, people are on this side of the lane, essentially, the one thing I get very concerned about is people not, number one, trying to merge into your lane, and not even recognizing that your car is even in that lane. So, I'm on the lookout for that, especially even if I'm in the next lane over. This car could kind of try and merge into this lane, so I actually look out to see if there are no cars on 2 lanes over if there's a multi-lane highway. Anyway, that's just me. In this situation, I had this car coming over, and I would say, actually, this car probably was actually, maybe not here. This car actually was probably a little bit further up. Anywho. Slightly a bit further up. Let me accurately draw it. Maybe just like a little bit more than that. Alright. Anyway, I'm getting a little worried. This guy decides not to use his, this guy's deciding not to use it. I think he's not going to use his blinker in order to merge over to my lane here. So what do? I think that this guy doesn't see me. He's not going to see what's going to happen. So I'm like, okay. Logical thing to do is I can either swerve to avoid traffic. I can swerve over here. This area was empty at the time. However, that's not the right thing to do. Okay, that's not the right thing to do because there was a car. Although that area was empty, there could be a car coming up from behind here, and that could make things more dangerous, especially if you swerve suddenly. Especially you could tail out your car could spin around, and it could be all sorts of trouble. So what did I decide to do? I decided to do for the next, 1,000 feet or so, I straddled both lanes of traffic by just using the logic. So basically, I put my car here. This car, stupidly, did actually do exactly what I expected it to do. It actually merged into my lane. When it saw me straddle both of the half lanes, it finally figured out that it had to speed up, go past me, and then finally merge into traffic over there. And I avoided an accident altogether. While at the same time, the traffic behind me was able to maintain the same speed and be sure that, yeah, he can go ahead and do his stupid thing, and everybody else can go on with their business in their daily lives. That's essentially what again, it saved me for a second time, is this straddling two lanes. That doesn't happen often because of the fact that, obviously that situation, situations don't really call for that at all that often, but it does in certain circumstances, like in this case. People who don't know how to merge lanes without using a blinker, you guys are dumb, alright? Use a blinker, dang it. That's, So then I avoided an accident that way. There you go. So, does logic work? Yes. Logic definitely works. Logic is definitely helpful. Alright? 100%. You just have to be calm in a situation that could be potentially dangerous, and you have to be very aware on the road. Of course, I'm looking in the mirrors, I'm looking behind me, if you change lanes, you look, right? You make sure that you are clear before you change lanes. You look to your blind spots, you do the whole 9 yards. That's one thing that I actually did like in driver's ed in high school, is I will say that the process was correct. You probably guys did learn the IDPE process. So there was the identify, detect, predict, and execute process. This is the logical process that you should follow when you're trying to be a safe driver. Does it always work? Obviously you could still get into accidents. I've been in accidents before, but you avoid it as much as possible, right? You want to be a safe driver at the same time. So might be IPDE, but either way, you could switch them around and still be the same thing. All right, that's my driving lesson for the day. Wait, that's not the point of what I'm supposed to be doing. Okay, let me do what I'm supposed to be doing here. All right. Sorry. Habits, let me tell you. All right, there we go. Just gotta be realistic on the road, guys. Just be careful out there. All right. Now, let's move on here. All right, let's do 20 here. Let's do number 20. All right. Yeah, IPDE. Yeah, I remember learning this. Yeah, I think it was IPDE. Maybe it's not IDPE, but it's the same thing. Detect and predict you can switch around, because you can detect before you predict, or you can predict before you detect. If you have eventually when you're driving, you'll get a sixth sense, and then you're like, okay, I smell bad things happening. Let me move over here and let things happen over there. The last thing that you should do is road rage. Road rage, don't road rage, people. Please don't road rage. Okay, remember, you're putting yourself and many other people in danger if you road rage at somebody doing something stupid. Let somebody else do something stupid, okay? not you. You're smarter than that. Okay, please. All right. I trust everybody is smarter than that. All right. Getting mad on the road will not change a thing. If somebody cuts you off, if a guys follow me for a mile, stopped at a red light, got out of his car and bang on my window, okay. But you don't engage. The last thing you want to do is engage, Alex. This guy follows you for a mile, he stops at a red light, bang on the window. You know what? If he wants to have criminal charges because he decided to damage your vehicle, okay. That's on him. He made the action, not you. I said you gotta be the better person in that situation. You calm a situation down. You know, for example, when I got rear-ended by this girl in my car. And so I'm like, okay, let's, what do you do in a situation like that? You call the police, of course. And of course, I'm looking at her. She's pretty shaken up. She's shaken up, and I'm like, okay. It wasn't that big of a deal. It was just like a small, it was like, it just looked like she was a young driver, so of course you get shaken up when stuff like that happens. Same thing happened to me. And I'm like, okay, calm yourself. I said, do you want to call your mom? Do you want to call somebody so that way somebody's there for her? I'm like, I'll sit over here. We'll wait for the police. We'll take things calm. And then maybe like a few minutes afterwards, calm down. Everybody's chill. Got through the process. Everybody went on their way. Everybody's great. People feed off of the emotion. So that's why I decide, hey, sometimes you step in, and sometimes not. But you want to calm yourself in that situation and just proceed things through carefully and logically. All right. Anyway, I'm taking too much of my time here. All right. Let me try this here. All right. Number 20. Number 20. According to the Centers for Disease Control and Prevention, 19.6% of children aged 6 to 11 are overweight. A school nurse thinks that the percentage of 6 to 11-year-olds who are overweight is different in her school district. Okay, so let's set up our null hypothesis here. Let's say we're doing a study here. We're doing a null hypothesis. What would be the null hypothesis here in this case? I'll tell you that what would be the null hypothesis here for number 20? Please type it out. What's our base case here? 19.6%. Good. Now, all right, so really quick, Vince, how would I put that as a decimal? How would I put that as a decimal here? Because I agree, 19.6%. 0.196, good. Nice. All right. So that's going to be our null hypothesis here, our base case, 0.196. I know it seems a little weird that I ask you that question, but it will be relevant here for the next section, so you'll see how that works. All right. Let's talk about the alternate hypothesis here. Now, what's the alternate hypothesis? Is it going to be... So again, we can write down the same numbers, P and 0.196. Remember, the number's not going to change. Now, the question is, do we have less than, bigger than, or not equal to? Less than, bigger than, or not equal to? Alex says does not equal. Let me put this here. Okay, very good. Both of you are correct. It is not equal to. Now let's take a look about why. Again, it says that the school nurse thinks it's different than her school district. It's different. So it doesn't say it's less than. It doesn't say it's bigger than, but it just says it's different. So that means it's not equal to here. Okay. So because it says it's not equal to, what type of test do we have here? Do we have a left tail test, a right tail test, or a two-tail test? Do we have a left tail, right tail, or two-tail? All right, very good. That's right, a two-tailed test. All right, good job. Okay, so far so good with that. Perfect. All right, no problem here so far. All right, now that we have a pretty good idea about how to do this null and alternate hypothesis thing, okay, we've looked at it in a couple different ways. Now, what we want to do is we're going to look at how to do this in many given different situations, all right? But we're going to start doing that here in section 10.2. All right, so let's go through this process here. I've given you a lot of information here, no question about it. We've talked about how to drive. I've given you a lot of information about it. Talked about the logic. Yeah, there you go too. All right. But where does this fit in with the other stuff that we've kind of already stated here as well? This type 1, type 2 error, doesn't seem like I've mentioned that at all. This level of significance, it doesn't seem where I mentioned this at all. Now let's put all this information from 10.1, let's put this together here. So I'm not going to do a ton from 10.1 here. I'm going to do a lot for 10.2 here, and you'll see exactly how this all goes. You'll see this on the screen right now. All right. So what's the first one that we're going to do here for section 10.2? In section 10.2, we're going to be looking at a good old friend of ours that we looked at back in chapter 9. And that was talking about our population proportion. So if you remember our population proportion, we did a confidence interval regarding that. All right. We did that. We also did normal CDF with a population proportion. Remember that was the X over N. Okay, stuff there. People we asked a question said yes to a question, whatever. All right. How does it work for a hypothesis testing problem? All right. So let's look at question 8. Question 8 asks, what assumptions must we make to do a hypothesis test for a population proportion? Okay. Now we do have some things here. You will get homework questions. Will ask you this first part, so that's why I'm stating this here. All right, first of all, it has to be a simple random sample or data from a randomized experiment. So it has to be a random sample, okay? Let's say you're using people. Well, those people have to be randomized in nature. That's fine. Once again, this pops up once again. That is, NP times 1 minus P must be bigger than or equal to 10. This actually also occurred back in chapter 9 when we talk about confidence intervals. And once again, this also pops up once again here. So have to have a big enough sample size in order to qualify as a proper test. All right, so we want to have that happen. And of course, the sample values are independent of each other, meaning to say, like every person you survey is going to be independent. Okay, so one doesn't influence another. They have to be all independent. They'll have to give you a independent answer, and that's pretty much it. Fine. Okay, so those are the 3 assumptions here. Alrighty. So let's take a good look here at number 9. And so what I want you to do now, ladies and gentlemen, is what I would like you to do now is to please go ahead and I'm going to actually expand this a bit. I want you to please go ahead and copy down this process here. I'm going to go over, yeah, all right, so we'll do that. We're going to copy down this process here for number 9 because we're going to do it step by step here, okay? And I want to be sure that everybody here is on the same page. So I'm going to do these first 3 steps first, and then we'll do the latter 3 steps after that using the calculator. Latter 2 or 3 steps. Anyway, so let's look at step 1. Step 1 here is to determine the null and alternate hypothesis. So how do we... All right, maybe I should read the question here at the top. That would be helpful. How do we perform a hypothesis test using the p-value method for a population proportion? And we're going to get to this quote-unquote p-value here in just a moment when we get to the end of the problem. But we need to set up the problem here appropriately. Now, to set up the problem here, this is where this first step comes in. We're going to determine the null and alternate hypothesis, exactly the same way that we just did here in the previous examples from the previous section. So do understand, I'm not doing anything different here for the first couple steps. So again, we have, in this case, P is equal to the population proportion, whatever that's given to us in that problem. Our alternate hypothesis, again, less than, bigger than, or not equal to, for our left, right, and two-tail. Okay? So, again, in a separate step, just in case, I always put this as a separate step, and I know it may seem a little weird. But I put it as a separate step here. I determine the type of test. And I know this seems strange, but I do this on purpose because you should have it as a reference for what we may do on the calculator. So having this as a separate step will be incredibly helpful. And then number 3, we're going to state the level of significance, okay, which will be given to you as either the most common ones you'll see is 0.01, 0.05, or 0.10. Okay. Blah, 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 giving you things. All right. That's nice. Let's go to the book here for a second. And do an example here. Here. Okay, which ones did I do? Give me just a second here, guys. Okay, so let's look at number 21. All right, so let's look at 21 here. All right, so let's read off number 21. We'll do this together here, and we'll get this done. All right. So in 1994, 52% of parents with children in high school felt it was a serious problem that high school students were not being taught enough math and science. A recent survey found that 256 of 800 parents with children in high school felt it was a serious problem that high school students were not being taught enough math and science. Do parents feel differently today than they did in 1994? Use the 0.05 level of significance. Okay. All right. Let's go ahead and see what we can do with this. We're going to do steps 1, 2, and 3 here. So let's at least get that out of the way. All right. We may take a break after this. I want to see how far I can get with this example here. I need to do this example here first, Rabia. I know I'm going a little over time here, but I do need to do this first example. It's very important. All right, so we need to determine the null and alternate hypotheses. So what is the null hypothesis here for this question? Okay, 0.52. That is correct. So we're going to use... okay, so going back to our handout here, take a look. We're going to use P here is equal to 0.52. All right, P is going to be our guy here for this section. So P here is equal to 0.52. That's going to be our proportion. All right, population proportion. Perfect. All right. Okay, nice job, Vince. Okay, all right, so how about our alternate hypothesis? What's the claim that it's making here? What's the claim in this case? What is our alternate hypothesis according to number 21? But I should probably make that a bit bigger. Probably is hard to see. Sorry. There we go. Left tail less than? Look at that carefully. I made that a little bit bigger, so... read it carefully here. Is it less than? What does the question really say here? All right. Read this very, very carefully. Read all the way to the end. Remember, what's the biggest crux of the problem is you're making a claim. That's correct, Alyssa. Yes. Very good. So we want P is not equal to 0.52. So looking at this very carefully here, it says, do parents feel differently today than they did in 1994? So although they may have an opinion about whether or not they're being taught enough math or science, the researcher in question here is, do they just feel differently? Whether it is less than or bigger, or less than, it's not less than, it's not more than, do they just feel different? So is it not equal to 0.52? The survey results don't matter. This is just the question that's posited by the researcher. Are there any questions about that? All right. Okay. Yeah, as I mentioned here, you got just, yeah, sometimes it just takes a little time just getting used to reading the question here. So got to be very careful about that. So what type of test do we have here? Step 2. Remember, step 2 here is we're going to do a test. Okay, so we're going to take a type of test. What type of test do we have here in this case? A two-tailed test. Good. We have a two-tailed test. Now, like I said, I put this as a standalone step, but it is an important standalone step. Okay? The two-tailed test is correct. Now, step 3 here is going to involve the level of significance. Now, this level of significance here is given to you in the problem. Again, this is not something that you have to find. This is given to you here at the very end of the problem, typically, which is, in this case, 0.05. So we're going to go ahead and put that in here. And we'll come back to that guy here at the end. Okay, quick question for you guys. Do you guys want me to finish off this problem? Or do you guys want to take a break and then finish it off? Finish problem? Finish the break? Okay, that's fine. Okay. Finish? Alright. We'll take a break and then we'll do another example after that, after we finish this problem. Alright. So, let's talk about what we're going to be doing here next. Let's look at step 4. Okay. Now, step 4, step 5, and step 6, and we'll discuss these. Step 4 here is to compute the test statistic. Now, in the middle of this process, we're going to be figuring out what's called a test statistic. Now, there is going to be a formula given the circumstances that we're using. In this case, we're using proportions. We have a formula here to find this quote-unquote test statistic. Now, you can write this down. If you want to write this down, that's fine. Now, we're not going to be using the formula here in an official capacity. You don't have to memorize this formula here. You can just go ahead and like take a screenshot and say, okay, there it is. But what is the test statistic here? Again, this is the formula here. Now, I rewrote it in the book. It's written differently. I rewrote it using a slightly different terminology because it's confusing how it's written in the book. But if you write it like this, it makes a whole lot more sense. It's given as x over n minus p divided by the square root of p times 1 minus p over n. So we are going to find this test statistic here, but we do need some pieces of information at the very least before we go ahead and put it together. So before we go ahead and move to step 5, all right? Yeah, sure. So before we go ahead and move to step 5 here, Yeah, right here. There you go, Sneaky. So before we move to step 5 here, let's go ahead and see what our x and our n is going to be here. And then we'll go ahead and put it together in the formula here, at least what it would look like if we entered in manually. So x here in this case is going to be the number of people who said yes to our question. That specifically is going to be 256 in our survey. And n here will be the 800 people that we asked. So if we use the formula here from our test stat, here's what it would look like. Now I have the notation there of Z0, but I rarely use the notation here in terms of the test stat to make it less confusing. I'm just going to label it as test stat. Alright. So this is what the test stat actually looks like here with all the numbers kind of filled in. Alright. So 256 over 800 minus 0.52 divided by the square root of 0.52 times 1 minus 0.52 over 800. Now, do I expect you to put this all in the calculator? The answer is absolutely not. Please do not enter this into the calculator. You will absolutely regret it. Alright, it is not fun to put in all that stuff in the calculator. I'm not going to, you probably say yeah. What we are going to do here specifically is we are going to go ahead and find this test stat here to go along with what the question originally asked. The question, let's go back to the original question here. It talks about the p-value here. The p-value, now that's what we're trying to find here, is this p-value. P standing for probability value. Now, how are we going to do that here in this case? Let's go to step 5. All right. Step 5 here is we're going to use the calculator, specifically the one-prop z-test, to determine this p-value. All right. All right, so we're going to use the one-prop z-test here. And now we have the values in place, and we're going to find this particular p-value here. So, does everybody have their calculator in front of them? Please, please type got it if you have your calculator in front of you in the chat. We're now doing the calculator portion of the program, and we want to be sure we get this down. Okay. Okay, hopefully everybody's got their calculator in front of them. All right, let's do it. Okay, so what we're going to do here first is we're going to go ahead and hit the stat key here. Go ahead and hit the stat key. We're going to go over to tests. Okay. And we want to go down to number 5. Number 5, which says one prop z test. Okay. That'll be number 5. One prop z test. And then hit enter. Now, all of you, regardless if you have the new school or old school calculator, will have this particular sub-menu. All right? Did everybody get here? Is everybody here at this point? Please say yes if you're there. At this sub-menu. All right, perfect. All right, everybody is pretty much there. So yeah, Victoria, are you hopefully there at this juncture? Going to hopefully cross my fingers and say yes. Yes, okay, perfect. All right, nice. Okay, So I want you to take a look at what we see here on the screen. All right. First of all, the number at the very top, it says P0. Now that P0 is going to relate to the population proportion here that we have at the beginning of the problem. All right. That's what this first value here it wants. So it wants the 0.52 to be put in that first spot, right, like just like so. All right. So that's why we have to set up step one, is just that we have to establish, hey, we got to put 0.52 in that particular spot. Now, let's take a look at x and n here. We have that defined from the problem. So that's going to be 256 and 800. All right. That part's easy. Now, here is the biggest reason why I put step 2 as a standalone step. This last part here on the calculator is going to define the test that we want to use here in this case. So this is the test that we want to use in this case. So if you see here, this first guy represents a two-tail test. You'll see this guy here represents a left tail test. And this guy here represents a right tail test. So by knowing what type of test that we have to use, we can use that to set up the stuff in the calculator to find our particular p-value. In this case, you know, it's a two-tail test, so you would highlight the two-tail and then hit enter if it's not on there already. But again, it goes two-tail, left tail, right tail. So by determining the type of test that we have and putting it as a standalone step, it's much easier for you to go ahead and easily do stuff here on the calculator. All right, that's why I don't put it together necessarily for step one, even though it's easy. Okay, so hopefully you have all that. Now, some of you don't have the color portion. Don't worry about that. That doesn't matter. You don't care. And then we're going to go ahead and go to calculate. Okay. So let's take a look at what we have here. All right. Now, first and foremost here, before we move on, does everybody have these numbers here on the screen? Please type in got it if you got these values on your screen. All right. Looking good, looking good. Now, at first, this is going to look a little strange, okay? I know this looks a little weird, all right? I want to go through this very carefully here, all right? All right. Now, of course, this is our test, not equal to. That was our two-tail test. Now, let's look at this very first value that you see here on the screen. The first value you see is going to be our test statistic. So the z is equal to minus 11 point da 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 is going to be our test stat, all right? So our test stat here is that very first value. So we get, if we plug all that in the calculator, that's essentially what we get. So that's why I wanted to say, hey, I don't want to find that, you know, the hard way. Let's do it the easy way, because we'll let the calculator do it for us. Now the p-value here, this can happen for p-values here. This is a good problem to kind of showcase, okay? So that way you guys aren't caught unawares. Now you see there, the p-value is the very next value below. This p-value here says 1.0396 da 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 e minus 29. Now this can happen here for many of these different type of hypothesis testing problems. Effectively, the way you would view this is, this would be 1.0396 times 10 to the minus 29th power. That's what this little e to the minus 29 means. Just like we have 1 e to the 99, it was the same thing here. X Mason's x plus y squared plus 2xy plus y squared. Alright, so we have a... So we have, again, this e to the minus 29 is essentially... Let's put a note here. Times 10 to the negative 29th, for example. Now this times 10 to the negative 29th, this does not mean that this value is bigger than 1. So do not get confused here. Alright, this means that basically you have 0.280s, 1 0.0396. All right, so effectively you have like 0.280 10396. It's a pretty infinitesimally small number. All right, irrespective of what we think, that is what it is. All right, so even if you were to round to 4 decimal places, you literally have pretty much close to 0. But if you wanted to look at it from a practical point of view, if you looked at, like, say again, let's say you had 3.14 times 10 to the negative third. Okay, this would be 0.00314. So don't forget how scientific notation works there. Just like that. Alright, so don't forget scientific notation. This is pretty much going to be 0 if we round it off. That's just how it's going to work. Okay. But 1.0396 times 10 to the negative 29th. There you go. Alright. So note here. You may run into this every once in a while. Remember scientific notation. Alright. Alright. Okay, so, next. Let's talk about step 6. Okay. Any questions so far, by the way? Any questions? Oh, this is just an example here, Rabia. This doesn't have anything to do with the problem. Just an example of scientific notation. So you can ignore it, basically, Rabia. You can just use, our p-value here is actually 0. Okay. I just don't want you to forget about scientific notation here if you see it on the calculator, because oftentimes people see 1.0396 and they think it's, well, just 1.0396, and they forget about the e to the minus 29 part, which is like a very small decimal part. So, alright. Alright. Step 6. Alright. Now, this is the final step here in this process. The final step. Alright. So, in the final step here, we have to make a conclusion. Remember that conclusion here, we only get one of 2 conclusions. That's it. Okay? So we're going to get one of 2 conclusions. So how do we make the conclusion here? It says, if the p-value is less than the level of significance. So yeah, that guy that we haven't used so far is going to be used at the very end of the process. So here's the level of significance, 0.05. Alright, again, I make you say it as a separate step because then we use it later on in the process. In this case, this is where we use it. So if the p-value here is less than the level of significance, alpha, then we reject the null and accept the alternate. Otherwise, if it doesn't, then we accept the null and reject the alternate. So the real question comes down to this. All right, let's go over the real meat and potatoes. It says is 0. Oh, actually, why am I going to say 0? Let me put the formal one here, even though, you know, let's see if we is 1.0396 times 10 to the negative 29th less than our level of significance here, which was given to us as 0.05. Yes or no? So yes or no, guys. Is 1.0396 times 10 to the minus 29th less than 0.05? Okay. The answer is yes. So what's our conclusion here? What conclusion can we make based off of this? We're not talking about unusual here, Victoria. We're just talking about which one of these two conclusions on the left here do we have to make. Reject the null and accept the alternate. Alright. That's correct. Very good. Okay, nice job. This is like I said, that's the nice part about these problems. You only get 2 final answers. That's it. One of those 2 final answers is going to be our guy. In this case, we said yes, that p-value is less than the level of significance, so we reject the null hypothesis, reject the null, and accept the alternate. And there we go. We're done with that problem. 100%. Any questions about this example? Well, I will say this, Sneaky. It's a long problem to explain the first time around. When you do it the next time around, it's much, much faster. I just need to be able to explain it the first go around because there's some moving parts. But when you do it a second time around, it's significantly faster. Because what I want you to get is like, hey, we have a, this is the template with the steps. Apply the steps. But in reality, it's very, very fast. If you guys will allow me, I know you guys said to take a break, but we have 15 minutes before class is up. If you'll allow me to do one more example here from this section, if that's okay with you guys, I want to do one more question, and it will take less than 15 minutes to do. And I'll show you, Sneaky, why at least having the template here will make it significantly faster. So, is that okay with you guys? I do apologize today. Did promise a break, but, let's get this bread. Okay. All right. All right. So let's do another problem here. Okay. So let's look at which one I want to do. I don't want confidence intervals. Screw that. All right. Here we go. Let's do it this way. All right. Let's go ahead and look at number. Let's do 18. All right. Let's do 18. All right. 18 says, Nexium is a drug that can be used to reduce the acid produced by the body and heal damage to the esophagus due to acid reflux. The manufacturer of Nexium claims that more than 94% of patients taking Nexium are healed within 8 weeks. In clinical trials, 213 of 224 patients suffering from acid reflux disease were healed after 8 weeks. Tested manufacturers claim at the 0.01 level of significance. Okay, let's do it. All right, let's go through the steps here. Step 1, let's identify our null and alternate hypotheses. So what's the null hypothesis here? What is H0? What is the null hypothesis? What's our P going to be equal to? You want to say 0.94? I want to say 0.94 too. Nice job, Vince. That is absolutely correct. Vince, Alex, I agree with both of you. Very nicely done. Very nicely done. 0.94 and that's at 94%. Okay. Seems fair. All right. So far, so good. Okay. What is the alternate hypothesis? Again, use the same letter and number here. What is our alternate hypothesis? Less than, bigger than, or not equal to? Okay, nice, Alyssa and Vince. Good. The answer is bigger than. That's right. So if we look here carefully, right, more than 0.94. So the manufacturer of Nexium claims that more than 94% are healed. Perfect. All right, excellent. All right, so good. That's right, Rabia. Absolutely right. Okay. So far, so good. All right, so that's step one. Step two, we have to determine the type of test. What type of test do we got here? We have left, right, or two-tail. All right. See how, okay, good. We got right tail here. Good. Good, good, good. All right. All right, here with step three, let's go ahead and put down the level of significance here. All right, and we're given 0.01, so I'm going to use that at the end here. Good stuff. You can see how things go pretty fast here, hopefully so far. You get those first three steps are boom, boom, boom. All right, good stuff. All right, next we are going to need to find that test stat. So let's at least establish our X and N. First and foremost, let me go back to the handout here. Actually, before I do, what's our X and what's our N? What is our X equal to? What is our N equal to? All right. Yes, yes, yes. All right. This is what I like to see. Some 213 and 224. Perfecto. All right. Now, we could just easily lock those into the test stat. So if we need to write it out for whatever reason, then the test stat here is going to be, again, 213 or over 224 minus 0.94 divided by the square root of 0.94 times 1 minus 0.94. Now, like I said, you don't have to enter this in the calculator, but if you want to use it as a reference just in case, if you felt that you put in numbers wrong, you at least have a little reference of what you can use. So, I'm not saying to obviously put this in the calculator. Alright. We'll come back to that. Let's go to step 5. Let's find our p-value here. Okay. Alright, let's put this in our calculator. Okay. So we're going to go back. Let's put this together here. So let's hit the stat key. We'll go over to tests. We'll go over to number 5, one prop Z test. Okay, first things first here. At the very top, we're going to go ahead and put our p-value, what we not. So we want 0.94. That was our population proportion here for the Nexium trial, guys. Our X here, stated to us as 213. 224 for our N. And we have, in this case, in step 2, we have a right tail test. So this is two tail, left tail, right tail. We'll cover that last one there and hit enter on that guy. Then we'll go to calculate. Okay. And so let's take a gander at what we have here. Again, we only care about these first two numbers here. So we first have our test stat here, be 0.6865. Okay. We also have our p-value here given to us right below it at 0.2462. Using our regular MO of 4 decimal places, just in case. Okay. Alright. I hope everybody got that on their calculator. Please, actually, let's do that. This formula is just used to verify our numbers? Yes. You don't have to put that in the calculator, but in case if you want to verify Yeah, it's just ugly to put in a calculator based on how much you see there, Rabia, to be honest. But just in case if you wanted to, you have it on hand. Um, everybody type in "got it" in the chat if you got these numbers here on your calculator. Let's just be sure everybody entered it in correctly, and they got these good old values here real quick. Alrighty. I think we're in good shape here. Okay. Very nice, very nice. Okay. Now, let's not forget the last step here. Last step here is we got to make our comparison. See what conclusion we're going to make. So, we got to compare the p-value and the level of significance. So, is the p-value 0.2462 less than 0.01? So is 0.2462 less than 0.01? Yes or no? No. Okay, good. So just pointing this out here. I'm just you're not wrong, Alex and Vince. I'm just pointing out the logical process here. Just answering the question here, is this less than? The answer is no. So then the answer here, because it is no, we are going to exactly what Alex and Vince have suggested here. We're going to go ahead and accept. We're going to accept the null and reject the alternate. Correct. Okay, and that's it. That's the end of the problem. So as you can see here, we did this much, much faster than the, of course, just explaining things through. But there you go. Just like that. Any questions? Any questions at all? Six steps, easy as pie with 6 steps. So you got a template down. You know, now you have a way about how to do that, and that's really not too hard. Just as a reminder here, there is a 10th question here on the handout, which is the critical value method. We are going to skip the critical value method. The only method I would like you to use here for this section is going to be the p-value method, okay? The method that I've shown you here to date, okay? So there's a critical value method, but we are not going to be doing that here for the section. So that is out. All right. All right. Wonderful job, everybody. I apologize for taking up the entirety of your time. But it was a lot of information. I totally understand. So, yeah, 10-1, 10-2 if you're keeping up with the assignments. Again, don't forget, though, Tuesday, 11:59 p.m., everybody. Remember that your tests and homework are due if you haven't done those for chapters 5 to 8, okay? So, don't forget that that's going to be due then. Okay. All right. Wonderful job, everybody, here today. Thank you for being so patient with me here today. I know it was a lot of information. I do apologize once again. But I need to get those examples out of the way at the very least for us to start understanding kind of what the pattern is for how we're going to be doing hypothesis testing in different situations. All right, so that'll take it for today, everybody. Thank you so very much. You guys know exactly where to find me. I'm on Discord. I'm on email. I don't smell. I don't think I do. All right. In any case, all right, everybody. Thank you so very much. You guys are absolutely wonderful. Thanks for sticking out with me. All right. Thanks for listening to me, the stories. And again, if you have questions, please feel free to ask me. You know, like I said, you know where to find me. And as always, everybody, stay safe, stay healthy, but most importantly, stay sane. All right. Have yourself a great day. And we will see you next week. Take care of yourselves. Have a wonderful weekend. All right? All right. We will see you all later. Take care, everyone. All right. Everybody, take care. See you later, everybody. Bye. Bye, everybody. Have a great one.